Welcome to the fourth lecture in Module 5, which deals with the response side of the HTTP protocol. Now, this response side looks very similar to the request side. Previously, there was a request line. There's a response line in our case. It has a header, and there could be a message body associated with the response as well. And typically, there is on the server side. So after delivering this response, the server closes the connection, which was the default behavior prior to HTML 1.1 with HTTP, not HTML. Okay. After delivering the response, the server closes the connection, which was the default behavior prior to HTTP 1.1. With HTTP 1.1, there can be a persistent connection, so the connection could be maintained. Now, the response line is, again, the first line of the response that's provided by the server back to the client. And the first thing it has there is a status line. You're probably used to seeing something like this. And this status line consists of three parts. The version of HTTP that you're using, a status code, and then some English phrase that describes the status code. So here's an example. And again, as I've mentioned, you've probably seen these. Here, HTTP 1.1. 200 OK means that it was able to satisfy the request. Another one that's very common to see is, again, the version of HTTP that you're working with. 404 means the page is not on the server. And so this is a common error that you see. 404, English phrase is not found. The resource could not be found on the server, in other words. Now let's look at these status codes from a web developer's perspective. Web application architecture developer, you should understand what these status codes mean. So anything in the 100 range, those are provisional responses. So what is a provisional response? It's just something that requires the requester to take some additional steps. A very common one is this 101, which says let's switch protocols. Let's move from HTTP to HTTPS, a secure protocol. And so this is letting the client know that I'm moving to a different protocol. You should do the same. And this is a very common one. We'll talk more about HTTPS at the end of this lecture. 200 range is all for successful events. The 300 range deals with a request that was redirected. You made a request, and the server said, I'm going to let some other server handle this request. 400 is the one, the range is used for errors. So there was an error in the request which prevented the server from being able to process it. And 500 also deals with error, but this means there's an error on the server side. There was some type of internal processing error. So you need to be able to diagnose the 400 and 500 errors when you're dealing with a web application architecture. The complete list of these codes, understanding these ranges, the 100, 200, 300 through 500 ranges is important. But if you need to know the specific error, again, typically an English phrase is provided for you, but you can actually look at this RFC 2616 to find out the official description of what that status code is. The next thing that we see here are the header fields. So the header fields in a response allow, again, the server. We saw header fields on the client side where you could pass information about what language you expect, or another one that's common there is the browser that you're using. A lot of times that information is passed. The server can also pass information back to the client side, telling it a little bit about what it's going to send to the client. So these header fields have the same format as in the request. So it's the name of the field, colon, and then the value. So here are some examples. Accept ranges allows the server to indicate the acceptance range for the request that can be made. The age, this is the sender's estimate of the amount of time since this response was generated. So this gives you could use this to look at how responsive an application is. Location, used to redirect the recipient to a location other than the request URI. And then proxy authenticate allows the client to identify itself to a proxy, which requires authentication. So you can, again, look at a response and you'll see these header elements in the response itself. I'll show that to you shortly. Lastly, the message body. The message body, just like on the client side, there has to be a blank line between the header and the message body. And the response to a head request is really about the only one that's not going to include a message body. Almost all of these other responses are going to include something. Typically, you're asking for some HTML page, and this is where it's contained, in the message body of the response. So this is it. The requested resource, in other words, typically the HTML is included in the message body of this response. Let's take a look at some examples of this. Let's take a look at the response when we issue a request to get www.unm.edu. And this is the previous request that we made, and here's the response. Again, it shows that it's, here, first of all, you'll see the status code that was returned 200 OK, and it showed here again when we view the source. Here are some of the header values. You'll see the content length, for example, the encoding. And if you look at the response itself, the body of the response, if you click on this this tab, you'll see that the actual response, the HTML that's in the response is provided here. So this is actually what was returned and rendered in the browser. Now let's talk about the HTTP Secure Protocol. Sometimes you just see this referred to as HTTPS. And it's a combination of the HTTP protocol and these underlying security protocols, SSL, TLS, secure socket layers and transport layer security. These two are combined in order to create HTTPS, and it's built on top of public key infrastructure. What HTTPS does is it enhances the HTTP protocol by providing encrypted communication between the client and the server. And this is often used if you go if you browse to a bank, or if you try and execute a transaction online that involves credit cards or something like that. Typically this should be encrypted using HTTPS, so that those that are listening in on the communication, and this is possible to do through wireless networks or through other means, if they're listening in, they're just going to see encrypted bits. Now, the trust associated with HTTPS is based on certificates that authorities distribute. And typical certificate authorities are VeriSign, Microsoft, and so forth. They embed these in your browser. So these certificates are in your browser, and that's how when you, and we talked previously about this negotiation that takes place as a part of HTTP. So if it wants to move to a secure HTTPS, there's a negotiation. The site that's asking for this has a certificate that it can provide to you, or your browser can check it, and that's what's happening, this public key infrastructure that's under the hood, making sure that this communication is encrypted and safe. So what you'll see is if you go to a website that's using HTTPS, you'll see that it begins with HTTPS:/// and that typical port, rather than port 80, port 443 is by default reserved for HTTPS communication. So this completes Lecture 4 in Module 5, which deals with the response side of the HTTP protocol.